We are still on solar systems. As we started with solar panels, we are going slowly. Each components explained well. Now solar panels, we are soon ending solar panels. Then we shall go on regulators. Because from solar panel, you connect a regulator before you connect a battery or your appliances. Okay. Now, we have seen solar panels, how it functions, how it works, on how it receives the sun with an effect which is called the photovoltaic effect to turn sun into electricity. Now we want to see, how do we connect these solar panels? Do we connect the solar panels anyhow? Is there any way how we connect solar panels which are two or more? Okay, there are two types of connecting them. Either you connect them in series, which you have looked to the last video, check in the last video, the series connection. And our series connection, our aim was to increase the voltages and current was constant. Okay, now there is another way of connecting, which is the parallel, which we are going to look at today. The parallel connection in parallel. And this is our topic today. Parallel panel, connecting panels in parallel. Connecting our panels in parallel. We have seen in series in the last video. Today we are looking at parallel connection. Why do we consider to connect solar panels in parallel? What is the logic behind? As you can see, we want to see, why do we need to connect why do we solar technicians, why do we need to connect our panels in parallel? What are we supposed to focus on? There is voltage. We need voltage. We need current. We need the power. Okay? Because all this, we need it to charge our battery. Without voltage, we can't have current. And our batteries will not charge. Okay? Now, what if we connect them in series? How we have seen in the last video. We have seen why we connect solar panels in series. If you have not watched, go back and watch the video of why solar panels are connected in series. We are this time round, we are basing on parallel. Okay? The parallel connections. Why do we need to connect solar panels in parallel? Okay? Let's try to say, in parallel connection, we are looking at increasing the current. In series connection, we are looking at increasing the voltage. Now in a parallel connection, we are looking at increasing our voltages. I mean our current. Okay? Not voltages, current. But the voltages will be constant. Our voltage will not change, will remain at Z. Like the voltage of one panel, let me give you an example. Here we have, okay. We have this is our panel. One panel, two panels, three panels. This is panel A, panel B, panel C. We want to connect this in parallel. Okay? We have positive, this side negative. Because every panel has two terminals, a positive terminal and a negative terminal. Here, negative terminal. A positive terminal. Here, a negative terminal. Okay? These are our solar panels, 3 of them. We want to connect them in parallel. Remember I said in our logic behind connecting in parallel is we want more current because our system is not working well. So we need more current so that our system will work well. To need more current, we shall connect the panels to give us more current in parallel. Connect them in parallel so that we receive more current, but the voltages will remain constant. The voltages will not change. The voltage which I am saying, the voltage of this panel, the voltage of one panel will not change. For example, let us say we have 20 volts, 5 amps, 100 watts. Even here we have 20 volts, 6 amps. This will be 120 watts. Then here we get 20 volts, 4 amps. This will be 80 watts. Okay? Every panel has wattage. That's why a lot of people look for wattage. That is the power, wattage. And every panel has amps. This one, our first panel A, has 20 volts. On the open circuit, it will show you 20 volts. If you measure here and here, it gives you 20 volts or 21. Then it will be having 5 amps. We are showing the amps. Then these are 100 watts. Because watts, to find watts, you multiply 20 times 6. Where you find this formula, power is IV, which is measured in watts. Okay? This I is the current, which is in A, times the voltage. There you measure in watts. Which watts are? Every panel has 80 watts, 120 watts, 100 watts, 40 watts. Now this is just an example for you to understand. Now, we shall, in parallel connection, master this. If you're connecting your solar system, if your solar system needs high currents for your machines to work or appliances in the house, I take this to technicians who are going to install any solar system. Consider current to be important. Consider voltage to be important. Those two things are very, very crucial when you are connecting. Okay? Because without knowing the current, you will not estimate well how many appliances or how many your inverter or how many the charge controller which you will need to run the machines for calculated time. Okay? Now, we said in parallel connection, our aim is to increase the current, not voltage. Voltage will remain constant. Which constant? The voltage of one panel. This panel has 20 volts, this panel has 20 volts, and this panel has 20 volts. Okay? Our voltages will remain 20 if we connect in parallel. 20 volts will remain constant. If we connect in parallel, the 20 volts will not change. If you are measuring 20, and if your system is working on 20 volts, that is okay. Connect the system in parallel because the 20 volts will not change. Okay? But the current will change Note this, the current in parallel connection always changes or increases. We are targeting current now. In parallel, we target current. You should master this. If you connect your solar panels on the roof or anywhere or in the standalone poles, note if you connect a positive on positive, a negative on a negative, your aim, you are boosting the current to increase. The voltage will remain the same. A voltage of one panel, it will remain that voltage. That's why I'll say this 20, this 20, this 20. When you measure after connecting on parallel, you connect this positive, you connect this positive and this one, then you connect also this one, and you connect this negative on this one, this negative on this one. Let me show you. This positive, you connect it here on this positive, then positive, positive on positive. Then here we shall have our positive terminal. Okay? Then we connect also negative on negative, negative on negative. Then we shall have here our negative terminal. Okay? If you measure this terminal and here, after connecting these all solar panels in parallel, positive, you connect them at the same point. Negative, you connect them at the same point, this negative terminal. Here, if you measure here, our measurement here, voltage will be 20 volts. This is what I was meaning, that the voltage will remain constant. Okay? The voltage of this system will remain constant. But the current, here we have panel A has 5 amps, panel B has 6 amps, panel C has 4 amps. These current are going to add up and they will increase. In parallel, we increase current, but the voltage remain constant. It doesn't change. Okay? The voltage of one panel is the one which will reflect after adding them, after connecting them in parallel, positive on positive. All positive terminals are connected on one terminal. Then all negative terminal are connected on one terminal. If you measure voltage, will give you the voltage of one panel, 20 volts. There you will know that your system is okay in parallel connection. Now when you measure the current, this current will increase. 5 amps plus 6 plus 4. Okay? It will give you, this is 10, 15. It will give you 15 amps. All panels, current has increased. And if you measure here, our current on these positive terminals, the output, it will give us 15 amps. It gives us 15 amps. 15 amps, we have added the current of this panel, the current of this panel, the current of this panel, and this is 6, 4, 5, 6, and 4, which we get the 15 amps. And here, this is our system. This terminal will be connected to a regulator. We are aiming to increase the current. The voltage constant. We need our 20 volts constant. Even though you add another panel, like this, positive, negative, you connect this negative here, you connect this positive here, either it is having 20 volts, the same sizing, 5 or 7 amps. This is 140 watts. Okay, Still, our 20 volts will not change because in parallel connection, current increases or current changes, whereas the voltages remain constant. They don't change. That is only in parallel connection when you're connecting your solar panels. When you're on a roof, each solar panel has two terminals, a positive terminal and a negative terminal. Okay? Connect all positive terminals together as we have done like this. Let me give you a clear diagram which will show you. Is it clear for you? This is our one panel, second panel, okay, let us use two panels. We have, it has positive, it has negative. Positive terminal, negative terminal. Positive terminal, negative terminal. Okay, this is our negative side, this is our positive. This is one panel, panel A, panel B. We want to connect this in parallel. As I said, connect all positive terminals, put them together. Let's do like this. All positive, and we get one output. This is our positive output. Okay, we have combined the positive terminal together. The same thing we do it also on negative terminal. Combine them together, you get one common negative terminal. Negative terminal also combined together. Panel 1, panel 2, negative, that is parallel. Here, if this panel was 20 volts, and this panel is 20 volts, here it will be 20 volts. It will not change. The voltage will remain constant. But the current, if this is 5 amps, and this is 6 amps, the current will add on 6 plus 5, that is 11 amps. Current will increase in parallel, whereas the voltages will remain constant, will not change. As you can see in parallel, positive terminals are connecting together, negative terminals are connected together, and this is the parallel connection. In series connection, voltages increases whereas current remain constant. In parallel connection, current increases, voltages remain constant. If you are on your roof, you want to mount your solar panel, you should know these things behind you, behind your head. That what do I want? What is my system going to work on? Am I supposed to increase the voltages? Is my system a 32 volt? Is my system a 40 any voltage? You should know the voltage of the system, and it will give you, you first study the regulators or your inverter. Are they going to work on 12 volts? Are they going to work on 24 volts? Okay. Are they going to work on 36 volts? You should know which voltage are you going to produce. Then knowing that, you will know that if I want to increase the voltages, then let me do the series connection. Then if you're going to work on 24 volts, or 12 volts. Okay, if you want to work on 12 volts and you have your 3 panels, you can connect them in parallel so that you increase the current, the voltage will remain constant. But if you want high voltages, to increase the voltages, connect them in series, where series voltages increases, current remain constant, and in parallel current increases, voltages remain constant. Those two things, any technician or electrician, solar technicians, you should get to note this. Do not do any mistake and you fail to your system, and your system fail to work because of not knowing these principles of series and parallel. Now we are going to see, we shall have a comparison between, is it good to connect in series or is good to connect in parallel? Which is best? Okay, some people may think that it is good to connect in series, others may think that it's good to connect in parallel. Okay, and others may say it is not good to connect in series, whereas others will say it's not good to connect in parallel. Which is good? Which is better? Are we supposed to connect solar panels in parallel or in series? Because we have seen the difference. In parallel, the difference. In series, we need voltages. In parallel, we need current. And yet the system needs current and voltages. We shall see also how to combine it, which we shall call it a series parallel connection. We combine series and a parallel together so that we charge our battery, so that we shall use the power. It has those connections, series connection, parallel connection. Then if your system needs a series connection, you want to boost current, you want to boost the voltages, it means you have combined the two connections. You don't do the series, then turn into a parallel. That is a series parallel connection, increasing the voltages and the current. But today we are seeing parallel connection to increase the current. Okay, thank you for watching, and that is the parallel panel connection. I see you in the next video where we shall compare which is good. Is it parallel or series? We shall do a small calculation to show which will be good for us to connect either in series or in parallel for our customers and for their system to work well. Okay, thank you for watching. See you in that video where we shall see the comparison of series and a parallel, which is the best. See you tomorrow. See you.